Hi, it's Chris here from the EQMod project. This video is going to show how to use the append on sync method to build up an alignment model. As you can see, I've already got my planetarium program working and it's connected to the EQASCOM driver. If I just open this up, I can show you what settings I have for the alignment options. First thing to note is that the point count is currently 0 and the sync data is also 0. If it's not and you wish to start afresh, then there are two buttons, one here and one here, that can be used to clear the data. It's important to realise that EQASCOM just adds points to its existing model by default, so you can return at any time to add new points. I shall probably go through a lot of the other options on here in a further more advanced video, but for the moment the only really important thing we need to look at is this user interface, which is set to the append on sync method. This is the default, but there is another option which is dialog based alignment, which again I think we'll cover in another video. Okay, so to start adding points, all we have to do is go to a bright star, and I'm going to start with one in the north. Here we go. Tell the telescope to slew to it. I've got the fast go-to turned on the simulator to speed things up a bit here. Now, the planetarium now thinks that we're pointing straight at that star. In reality, it's unlikely that your star will be on the crosshairs of your eyepiece. This is probably because of the starting position, the home position of the mount wasn't quite perfect. Or perhaps polar alignment or leveling errors or whatever. To simulate what we see through the eyepiece, I've got a little application here that I wrote. Obviously I'm not at the eyepiece at the moment. It's much easier to do these things in the daytime. So let's imagine that that's what we see when we get to the scope. So what we have to do is, using the slew controls of the ASCOM driver, move the star onto the centre of the reticule. I'll just pick a speed that's not too fast. Okay, now once we're happy with that, all we do is issue a sync from the planetarium. Sync. And on doing that, we have now added a point to our alignment model, as shown in the point count. Now you can add as many points as you like. Some people only use one close to the object that they wish to observe. Other people use a 3-point model. Some people go for 6, and some people go for 20, 30 points. It's entirely up to you, and it kind of depends on whether you're setting up every night or what kind of observing you're doing. For this demonstration, I thought we'd do a quick 3-point model. So what we really want to do is kind of add a triangle of points. So again, if I look north, I'm currently here, so we probably want another point somewhere up here. That'll do.
Slew to target. Slew complete.
And again, when we look through our eyepiece, we're going to see perhaps a small offset, and we just do the same thing as we did before. We open up we use the EQASCOM driver to center the star. Now, obviously I'm using the slew controls on the driver itself. Most people would be using a gamepad to do this. It's much more convenient. And once we've got it there, we simply issue our sync. If I move this out of the way, we'll see this snap on. I don't know if I had it covered before. And then we move on to our next star. So we've currently got one down here somewhere, we've got one up here somewhere, we probably want one in the east somewhere. So
slewing to target. Slew complete.
So again, we go to the eyepiece, we have a look. We center the star. We sync. And that's it. 3-point alignment done. If we have a look, just get rid of the eyepiece. If we look at the alignment data, we now have 3 points. We can see this by clicking on the points list. Obviously I already had it open. And you can see that we've got a triangle of points. That means that any go-tos within this triangle will be transformed and corrected by a 3-point algorithm. And that's what this red triangle is showing, that a 3-point algorithm is currently active. If I move around, let's pick a faster speed, you'll see that as soon as I move outside of that triangle, it now is applying a nearest point algorithm, in which it says that because I'm not within a triangle of 3 stars, I can only correct the pointing based upon the error of this point. And if I move back inside the triangle, again the correction is changed. The way this little indicator works is the large white circle shows the position of the mount, where the mount thinks it would be pointing. The small circle is the correction that's being applied. So if there were no correction, the little circle would be slap bang in the middle of the big circle. Because there is some level of correction being applied, you can see that it's shifted off to one side. And as we move around inside the triangle, the correction will shift about. Perhaps not a noticeable amount, but it does move. Okay, well I think that'll do for the moment. I shall do another video that explains some of the more advanced features of the alignment, particularly how to use these automatic save and load options, and perhaps also discuss a bit more about how this map display works and some of the things you might see when moving around the model.